In the next few examples, we're going to be factoring trinomials with an a value that is greater than 1. We're going to apply the same logic that we've used previously, but we're going to change some of the steps just slightly. Now, I would like to point out that the process I'm going to follow looks a little more complicated, but in reality, it works with any trinomial if it factors. So this is a good choice to use even when a is equal to 1. So example 1, factor 6x squared plus x minus 1. The first thing you might notice is we have a 6x squared, not an x squared. And what I'm going to do is notice that I'm going to call these a, b, and c. My a is 6, my b is 1, and my c is negative 1. I'm going to multiply a times c, that is the first number by the last number. 6 times negative 1, that is negative 6. Here's where our logic picks up. I want to find numbers that multiply to be negative 6, but add to be positive 1. Let's begin my list. I'll have 1, negative 6. Those add to be negative 5. Not it. 2 and negative 3. Those add to be negative 1. Not it, but very close. It adds to be negative 1, not positive 1. So I'm going to change my signs and make this negative 2 and positive 3. Now, what I'm going to do next is I'm going to break apart my middle term, the term that has the b. Because we just chose these values so that they add to be 1, I'm going to write this as 6x squared minus 2x plus 3x minus 1. So again, those values, those two terms, are coming from the middle term that I just broke apart. Next, I'm going to factor by grouping. We haven't talked about this much yet, but I'm going to group the first two terms, 6x squared minus 2x, and take out a greatest common factor. Well, the greatest common factor there is 2x. So 2x multiplied by 3x minus 1. We need to get good with greatest common factors for this. Now, my second two terms, 3x minus 1, they don't have anything in common other than 1. So I'm going to say plus 1 multiplied by 3x minus 1. So I am now at 2x multiplied by 3x minus 1 plus 1 times 3x minus 1. We have a common factor. 3x minus 1 is in both of these. So what I'm going to do is pull that term out. Imagine taking these together and pulling them out just like we do greatest common factors. Because it is a greatest common factor. It's just a binomial factor. This is going to become 3x minus 1. And then when I pull that out, my leftovers are 2x and 1. 2x plus 1. So that this factors as 3x minus 1 multiplied by 2x plus 1. All right, let's apply this to another polynomial. We have example 2, factor 5x squared minus 2x minus 3. Again, I will take the first value, a, multiplied by the last value, negative 3. 5 times negative 3 is negative 15. I need numbers that multiply to be negative 15 but add to be negative 2, my middle term. So let's run down the list. 1 and negative 15. 2 does not factor into that, is not a factor of 15. 3 and negative 5. That actually works. 3 plus negative 5 would be negative 2. So I'm going to rewrite this quadratic, this trinomial, as 5x squared plus 3x minus 5x minus 3. Again, these two terms are coming from the values that I just found that I claim, and I showed, add to be negative 2. Now let's group the first two. It appears that they only have an x in common. So x multiplied by 5x plus 3 is how my 5x squared plus 3x factors. And the second two, well, this 5x has a minus sign there. So I'm going to factor out a negative 1, which will result in negative 1 multiplied by 5x plus 3. So we have x multiplied by 5x plus 3 minus 1 multiplied by 5x plus 3. We have a common binomial factor, 5x plus 3. So that this factors as 5x plus 3 parentheses multiplied by x minus 1 because those are our leftovers. Once we take out the 5x plus 3 factor. All right, example 3. Factor 4x squared plus 19x minus 5. I will multiply 4 by negative 5, my first coefficient multiplied by my constant term. It's negative 20. So I need two numbers that multiply to be negative 20, but add to be 19. So that would be 1 and negative 20. That adds to be negative 19. Not quite. Actually, I can stop there. I can change this to be negative 1 and positive 20, and that will add to be positive 19. So I'm going to rewrite this as 4x squared minus 1x plus 20x minus 5. If I group my first two terms, they have an x in common, so that will be x parentheses 4x minus 1. In my second two terms, I could factor a 5 out of both. That's at 20x minus 5. It would be plus 5 parentheses 4x minus 1 when I divide by that. I have a common binomial term, common binomial factor of 4x minus 1. So this results in parentheses 4x minus 1. And the GCFs that I factored out earlier, x plus 5. So that 4x squared plus 19x minus 5 factors as altogether 4x minus 1 multiplied by the quantity x plus 5. Our last example for this, example 4, factor 9x cubed minus 21x squared plus 10x. We have one problem. We don't have a constant term. So before we can actually multiply a times c, we first need to factor out a greatest common factor. Our greatest common factor here is going to be x. And in fact, if there's ever a greatest common factor, you want to factor that out because it will make looking for those numbers that multiply and add tons easier. So in this case, my greatest common factor is only an x, so I'm going to write this as x, and I'm going to use a big bracket here. You'll see why in a moment. And when I factor an x out of each of those, that results in 9x squared minus 21x plus 10. Now I'll close my bracket. Now I'm going to carry on just like we've been doing. Okay, greatest common factor first, and then we'll multiply 9 by 10. My leading coefficient multiplied by my constant term. 9 times 10 is 90. So I'm going to run through my factors. I have 1 and 90. I have 2 and 45. Let's see, 3 and 30. I have 4. No, 4 doesn't divide into that. Let's see, 5. 5 definitely divides into 90. That would be 5 and 18. Let's see, 6. 6 and 15. And if you see the one that works, you don't have to continue going. However, I'm going to keep doing that. 90 divided by 7. No. 90 divided by 8. I don't think so. 90 divided by 10 is 9. So this would be 9 and 10. All right. Now I need a pair of these factors that multiply to be 90, which they all do, and also add to be negative 21. So 1 and 90 add to be 91. That's not it. 2 and 45 add to be 47. That's not it. 3 and 30 add to be 33. That's not it. 33. 5 and 18 add to be 23. That's not it. 6 and 15 add to be 21, which isn't what I'm looking for, but it's very close. So perhaps if I change this to be negative 6 and negative 15. That'll work. All right, equals x. Now I'm going to go use these to factor. The x that I factored out as a greatest common factor, I'm going to leave outside of my brackets because I'm about to put parentheses in a moment. So this is going to be 9x squared minus 6x minus 15x plus 10. And close my bracket. I'm going to group the first two, 9x squared minus 6x. And those have a 3x that I can factor out of them as a greatest common factor. That results in 3x minus 2. And a second two terms, negative 15x plus 10, have a 5 that I could factor out of those. I'm going to take that as a negative 5 because that 15 is negative. That will result in 3x minus 2. Now I'm going to keep my brackets around this and my x. I don't want to forget about my greatest common factor. But if you notice, we have a common binomial term, 3x minus 2. So this will factor as 3x minus 2 multiplied by my leftovers, 3x minus 5. Now I'll bring down my greatest common factor of x, so that this results in x parentheses 3x minus 2, close parentheses, open parentheses, 3x minus 5, close parentheses. Look out for a greatest common factor because, as I said, it will make your life a lot easier if you can find those.